These are really good problems for connecting like sort of symbolic rules and numerical patterns with visual stuff. And remember, we talked about how that's really good for your brain when you're trying to use multiple parts of your brain to solve a problem. These symmetry sleuths problems ask you to do just that. So I'm not going to go over every one. This isn't an answer key video. This is just to show you some general strategies that are going to help with these. So the first thing I'm going to start by doing is notice I've labeled all of the XY coordinates of each vertex so that we can use those symmetry operations on coordinates to move our shape around, and you don't have to sort of guess and check to figure out where each point is going to go if you flip or spin or slide the shape. We can just follow some of those symmetry rules. So I'm going to be using rotations, reflections, and translations, and on some of the later problems, dilations, in order to get shape A to shape B. So we're trying to see how could you use operations to basically land shape A on top of shape B in that location and orientation. So the first thing I did was label all the coordinates so that I could just do those operations to the numbers and move things into place step by step. So notice I picked out a point on here and I made it blue just to kind of have like a reference point. We're watching like where this point goes, where it needs to end up down on shape B below. And notice it looks like, first of all, we need to rotate this so that this pointy part of the shape isn't pointing down. Over here, it's pointing off to the left. So this thing does need to turn 90 degrees clockwise so that this point here is pointing off to the left like it is in part B. But notice if I just spun it, it wouldn't be in the right position. If you look at like this point here, if I spin this shape 90 degrees clockwise, it's going to be pointed up. And in shape B, that thing needs to be pointed down. So there is a rotation and there is going to be a reflection that we need to do to make a mirror image of it. And then if that doesn't land in the right spot, the last thing you would do is a translation. So a translation, sliding the shape, once you've got it in the right orientation, sliding it into the right position, usually a translation is the last step you're going to do. I would say a dilation would be the first step you're going to do. We don't need to do that in this case, but you'll notice in problems down here, we need to do a dilation. So I'll talk about that later. We don't need to worry about that on this one, but usually you would do that first, get it the right size, and then worry about the orientation, and then worry about the position. So you go size first, orientation second, and then position last, which is a translation, just sliding it into place. So I don't need to do a dilation. So the first thing I'm actually going to do is let's do a reflection, make a mirror image of this, and then we'll do a rotation. So first thing I'm going to do is a reflection. So I have a mirror image because B is a mirror image of A. It's also been rotated. So I'm going to reflect this across the y-axis. So if you remember what that does, that means I'm going to change the sign on my x coordinates and keep my y coordinates the same. So let's start with that blue point. So 10, 7 would become negative 10, 7. So negative 10, 7 would be there. Let's see, point 10, 9 would be negative 10, 9. So it would be there. 8, 10 would be negative 8, 10. 10, 12 would be negative 10, 12. And 12, 10 would be negative 12, 10. And hopefully I've done this right. Okay, it's a little bit messy, but close enough. So now I've got a reflection of that shape. I'll label all of my coordinates so I can kind of keep track of where things are. Okay, Now, the next thing I want to try and do is, let's see, let's do a rotation. So we want to do a rotation of this so that the blue point is pointed off to the left. So if I do a 90-degree rotation, it'll rotate it back over to that quadrant, but the blue point will be pointed off to the left. It'll be in the same position as it is in shape B. And then all I need to do is slide it into place. So let's try that. So remember, when you do a 90-degree rotation, what happens when you do a 90-degree rotation is your X and your Y values swap places, and then the signs on your X, Y values match the quadrant it lands in. So if I move this shape 90 degrees clockwise and rotate it, I'm going to rotate it around the origin because just gives me the easiest rule to follow so I correctly rotate it. Then that means it's going to put it in the first quadrant, so X and Y are both going to be positive. Switch my X's and Y's, and I'm going to make both coordinates positive because it's going to land over there in the first quadrant. So first one, the blue point, that negative 10, 7 is going to become 7, 10. And I can tell it's going to get a little bit messy, so I'm actually going to get rid of these coordinates right here just to clean things up a little bit. And then I'm just going to go around my shape and do each of these. Switch X and Y, make both of them positive, and that will rotate my shape over into the first quadrant where both X and Y are positive. So that means negative 12, 10 becomes 10, 12. Negative 10, 12 becomes 12, 10. 8, 10 becomes 10, 8. Negative 10, 9 becomes 9, 10. That should be all of them. Let's see if I did this correctly. Something looks a little bit off. Actually, looks like it's this point here, perhaps. Should now have my shape in the same orientation as the one below. So if it doesn't look like it, it means I must have messed up one of my coordinates. There, I think that looks right. So then the last step would be moving this shape down so it matches up, so it's in the same location as shape B. So I need to move it down and to the right. Remember, to do a translation and to preserve all the properties of your shape, you just do you do the same change in your X and your change in your Y to every point, and it keeps that shape intact and just puts it in a different position. Start again with that blue point, that tip, which now is in the right position. And so notice I need to move this down and over. So that means for each of my points, I'm going to do that same thing. So it looks like I need to move this down about 13 units down and 2 units over. So I would add 2 to all my x's, subtract 13 from all of my y's, but I don't actually have to do that to the numbers. I could just do this. Move that down there. I'm just going to show that that's the translation I'm doing. So I would take this point down and over, take this point down and over, I'm going to take this point down and over, and this point down and over. And that would match up all of the points with the original shape with all of the points in the new shape. So you're going to do that with each of these. And like I said, worry about the orientation first. Worry about dilations first. This one didn't have it, so resize it so it's the same size. All the side lengths are the same. Then worry about getting the right orientation. It's going to be a rotation and or a reflection. It might not be in the right part of the graph though. So the last step would be a translation, sliding that shape into place to get it in the right position. So the last thing I wanted to talk about, I'm not going to go over this one step by step, but what I'm going to talk about is how you would do a dilation. So remember, when you do a dilation, you have a scale factor. That scale factor multiplies all of the xy coordinates by that scale factor, and it also increases or decreases the side lengths of the shape by that dilation factor. So on this one, we just want to figure out, well, what is the scale factor for going from shape A to shape B? Notice it got bigger. So the question is, how much bigger did it get? What do I need to multiply all of my coordinates by to make A the right size? So what I'm going to do is I'm just going to focus on one side that I know the length of, which would be one that's lined up with the grid. So I'm going to look at this side here, and the corresponding side on the other shape would be this one here. So notice in A, that side has a length of 2, and in B, that side has a length of 4. So my scale factor must be 2, because it doubled the side length. The scale factor is equal to 2. So what I'm going to do is, first of all, like I did in the last one, I'm going to pick out kind of a reference point on each shape because that's going to help me later on get it into the right position. But what I'm going to do is now I'm going to label all my coordinates just like I did in the previous problem so that I can perform symmetry operations on the coordinates. I don't have to sort of eyeball it and twist the shape around in my head too much. I can just decide what operation I want to do, and I can do that to the coordinates like we did in the investigation 1 and investigation 2. So I'm going to look at this point here. So it looks like this would be negative 6, 3. And I'm going to do the same thing for all of them. I'll label all of my coordinates. So this would be negative 2, 2, negative 3, 4, negative 2, 5, negative 4, 5. So the first thing I'm going to do is my dilation, which means I'm going to multiply the coordinates all by 2 because my scale factor is 2. The side lengths are doubled. That means I need to double all of my coordinates to enlarge the shape. So multiplying these all by 2 would enlarge that shape accordingly. And then you can worry about any reflections or rotations to get it in the right position so that that blue point isn't pointed off to the left, pointed off to the right. And lastly, a translation to slide it into place.